A computer could be organized into three different sections: a CPU or processor, memory, and input-output devices. First, we teach our CPU a set of instructions which we call the ISR of our CPU. Then we have an idea in our mind that we want to implement. We want to write a program, right? So we write our program as a set of instructions that we already taught our CPU and put it inside the memory. Then we don't want the CPU to be or computer to be limited to our speed as a human until the CPU like execute the first instruction, now go to the second, and so on. We want it to be put inside an infinite loop. So we just simply give the address of the first instruction of our program, which is already in the memory. We put that address to the CPU and place it in in some location inside the CPU. We tell the CPU that this is the address of the first instruction of our program. Then the CPU would fetch that instruction from the memory, saves it inside itself, then figure out what it should do. How figuring out, or which we call the decoding. What do we mean by figuring out? Well, we already said that we teach the CPU a set of instructions. By teaching, we mean that we put a table that could be a RAM, a read-only memory. We put a table inside the CPU and tell the CPU that if you saw this specific pattern of zeros and ones, then I want you to issue these signals. I want you to execute these operations. So we give the address of the first instruction to the CPU. It has been fetched inside the CPU. Then by looking up this table, it figures out what it should do, what signals it needs to issue, and then it would simply just issue those signals and therefore executing the micro operations or micro instructions that just build that the combination of them means that the execution of the current instruction has been completed. At the same time, the CPU would increment the address of the instruction that we gave it. So therefore, when the current instruction has been executed, it would move to the next instruction in the memory and fetch the next instruction, then decodes it, executes it, and then move to the next one. So we say the execution of an instruction in the CPU includes, in a computer includes three different steps: fetching, decoding, and executing. So you see, when we need something, then because we needed the CPU, the computer, not to be dependent on our speed, we created this scenario that the CPU would be inside an infinite loop doing the fetching, decoding, and execution. Now you might say, well, what if I want the CPU to do something else? For example, I'm just teaching and recording this lecture, right? So right now the CPU is executing only one program, just recording everything that I'm saying, which includes the current program. Now when I write something here, this is actually another program. So the first one is just a recording program. The second one, this one, is a writing and editing program. So what happens when you see that both of them are, it seems like both of them are being done at the same time, while it's not that. When I'm doing this thing here, another program is being put inside the memory, or in our example, the RAM. Now we simply need to tell the CPU that this is the address of the first instruction of the second program, which is my editing program. Then the CPU, when the current instruction of the first program, which was the recording, has been executed, it just moves to the next address, which in this case we have changed it. So this case it would go to the first instruction, to the address that the first instruction of the second program or editing program resides on, fetch it. As it decodes it and executing it, the address would be incremented, so the next instruction would be also part of the next program. But all of these are being done at the nanosecond range. So we somehow feel like it is being done at the same time, while it's not. So to clarify it further, well, first of all, let's say that based on what we said, the part that we need for our CPU, the first one is that we need to transfer information between the memory, and by information I mean zeros and ones. And as I said already in the requirement section, that I explained all of these things, the binary, hexadecimal, and the transistor switches, and what do we mean by information in general, all of them in another course called creating a CPU using transistor and logic gate. So if you don't know them, please refer to that course or another course which is just an introduction to the or just teaches the fundamental and basics of the CPU and transistors and all of these electronic things. So based on what we said, that the building blocks that we need for our CPU, the first one is some wires to transfer information between the CPU and memory and input-output devices. So about input-output devices, we said that we put our program inside the memory. We might use an input device like keyboard to just give the information inside the memory and see the result that the CPU is executing on an output device like a monitor. But for now, the blocks that we need for our CPU, the first one would be a set of wires to transfer information. We call those set of wires buses. Then the second one would be we needed some place in the CPU to save information after we have retrieved them from the memory. For example, we need to have a place here to keep the address of the next instruction in the memory, or we need another place to save the instruction that we have fetched from the memory residing at this address. So we say other than the bus, we need something called registers. The registers are just simply memory cells, places that we could save information. The third one, we said that we need to teach the CPU. This teaching might be just a simple table that whenever an instruction is fetched from the memory, the CPU would just compare those pattern of zeros and ones with the entries inside this table, and well, if the one of them is just the same with the instruction, it would just issue the related signals. So as part of that could be a table or could be just other things. This is called the control unit, the section which has the job of having all those instructions that we are teaching, that we already taught. When we mean that we teach the CPU a set of instructions, we mean that part is a part of the control unit, which also checks and issues the signals. The fourth would be after the decoding happens, these are used for the fetching. After the decoding happens using the control unit, we need the execution, like adding, subtracting, and other things. The place for that, the block for that, is called ALU, or arithmetic and logic unit. Now, to simplify this further, I want to give an example here. Let's say that the first program is the recording program that we are talking about, and we have put it in the address of zeros to like 50 in our RAM. And the second program, which is the editing program, we have put it in the address of 100. And well, from the 100 it begins. So the first thing, well, inside the CPU we have a set of registers here. One of the registers, for example, is called PC, or program counter, which always holds the address of the next instruction inside the memory. For example, currently the first instruction that we want to execute resides at the address of 0. So in the PC would be equal to 0. Also, everything would be in the binary. Just for simplicity, I'm showing them in the other representation like decimal as well. So another register you would have called IR inside the CPU, which would contain the instructions that we are fetching from the CPU. For example, this is the first instruction that resides at the address 0, which the address is inside the PC. So this instruction should be fetched and put inside the IR. Then control unit here, which has that table, would compare the pattern of zeros and ones, this pattern with its entries, and if they match, it would issue the related signals, and therefore the ALU would execute the instruction. So first, we have a set of wires also that we call bus. Address bus would always hold the addresses of the next instruction. As an example, in our case, the first instruction is 0, so it would have 8 zeros on the address bus. Let's imagine that for our case, this would be, all of them would be 8 wires long. So 8 zeros would be put on the address bus. Then the CPU also issues the control bus to the RAM, telling it that please put your data in the address 0 on the data bus. So this data would be put on the data bus, and the CPU would just read them inside the IR register, And then the execution part might include the reading and writing to and from memory again. So the control signals, if you look at the arrows, the control signals are only issued by the CPU to other devices, including RAM and memory. The address bus are also from the CPU to other devices, but the data bus is bidirectional because we need to both write to the RAM and also read the data from it. So now about that, now let's say that the current instruction has been executed. The value of the PC would be incremented to 1. So next, these data would be brought inside the CPU IR register. Control unit would check again, issues the signals. The ALU would execute if it includes some arithmetic and logical instructions, and this would keep going. Now let's say, and at this case, I'm writing something here. When I'm writing something here, we are telling the CPU to execute another set of instruction, which the first instruction is on the address of 100. So the operating system somehow needs to tell the CPU that the address of the next instruction or of the first instruction of the second program starts at the address of 100. So the address of 100 would be put on the PC register 100. Then when the current instruction of here has been done, the CPU would just fetch the next instruction, which in this case would be in this address. Then after it is finished, the PC would be 101, 102, and so on. If the CPU wants, if you have finished the writing here, the CPU would need to go back to the address of 2. That's the process that I just explained is called interrupting the CPU. When it was executing a program, we just interrupted it to execute another program. So interrupting just means changing the value of the PC to a, because the CPU is not like a smart, it just is an infinite loop, just looks at the value of the PC register, fetches the data there, the instruction in that address inside the memory, fetches those instructions inside the IR, just decodes it and execute, and then move to the next address by looking at the PC register again. So by controlling the values in the PC, we are just controlling the execution of different programs from the CPU. So this was just a simplified version of what a computer is. And this was also some kind of review because you needed to already know these things. In the next lecture, we are going to enter the analysis of our CPU, the 8085 microprocessor.